On August 21st, 2025, our sun started broadcasting a signal. That's normal. It happens all the time. These signals last a few hours, sometimes a few days. Then they fade. This one didn't fade. It kept going, day after day, week after week, for 19 straight days, nearly 4 times longer than anything humanity has ever recorded. Here's why that number should bother you. The previous record for an event like this was 5 days. 5. Scientists thought they understood the physics that sets that limit, how long the sun's magnetic fields can hold onto a storm of trapped particles before letting go. 19 days doesn't bend that expectation, it breaks it. And the signal itself, harmless, radio waves, they pass right through you. But the machinery that produces a signal like this is the same machinery that hurls billions of tons of charged plasma across the solar system, the kind of eruption that fries satellites, blinds GPS, and in the worst recorded case, set telegraph offices on fire. The signal is harmless, the engine behind it is not. So when the sun runs that engine for 19 days without stopping, at the peak of its most active cycle in decades, the question isn't just how. The question is, what else can it do that we haven't seen yet? Because here's the uncomfortable part. For most of those 19 days, we didn't even realize what we were listening to. And the reason why reveals a blind spot in how humanity watches its own star. The routine detection. To understand what made this event so strange, you need to know what normal looks like. And normal, for the sun, is already violent beyond comprehension. The sun is not a quiet ball of fire. It's a churning ocean of plasma, threaded with magnetic field lines. And those field lines twist, tangle, snap, and reconnect constantly. When they snap, energy has to go somewhere. Sometimes it goes into a flare, a flash of light, and X-rays. Sometimes it launches a coronal mass ejection, an eruption of solar material blasted into space. CME equals billions of tons of magnetized plasma, moving up to millions of kilometers per hour. And sometimes, electrons, the lightest, fastest particles in that chaos, get caught, trapped inside arching magnetic loops in the sun's outer atmosphere, the corona. Picture charged particles spiraling around magnetic field lines like beads whipping around a wire. As they spiral, they radiate. Not visible light, radio waves. Astronomers classify these emissions into types. The one that matters for our story is called a Type 4 radio burst, a prolonged broadband radio glow from a population of trapped electrons. Type 4 burst equals radio glow from electrons trapped in coronal magnetic fields. Type 4 bursts are well documented. We've been cataloguing solar radio emissions since the 1940s, when wartime radar operators kept picking up mysterious interference that turned out to be the sun itself. Decades of observation built a reliable picture. A Type 4 burst switches on after an eruption, glows for hours, occasionally, in extreme cases, for days, and then dies as the trapped electrons leak out of their magnetic cage and lose their energy. The cage always leaks. That's the rule. So on August 21st, 2025, when the Solar Orbiter spacecraft, a joint mission between the European Space Agency and NASA, flying closer to the Sun than any imaging probe before it, picked up the start of a new Type 4 burst, nobody flinched. It looked textbook. An eruption had just left an active region on the Sun. A population of electrons was trapped and glowing. Standard. Hours passed, still glowing. A day, still glowing. Fine, long bursts happen. 3 days. 4. The burst was now brushing against the longest events in the record books. 5 days. It had matched the all-time record. And then day 6 arrived, and the signal did something no Type 4 burst had ever been observed to do. It just continued. Gravity moment 1. Think about what that means for a moment. Every model, every observation, every recorded event in 80 years of solar radio astronomy said this signal should be dead. The electron cage always leaks, but somewhere on our star, something was holding those particles in place. Or, and this was the possibility that made it stranger, Something was refilling the cage faster than it could empty. Either way, the sun was doing something we had never caught it doing before. Now, here's where the story picks up a complication that almost cost us the discovery entirely. The sun rotates. Roughly once every 27 days as seen from Earth, the whole star turns on its axis, and everything on its surface turns with it, including the region producing this burst. Radio emissions like this don't broadcast equally in all directions, so as the sun rotated, the source of the signal swung out of view of solar orbiter and into the view of whatever spacecraft happened to be positioned along the next stretch of the solar system. The sun's rotation turned one long signal into several short ones. And this is the blind spot I mentioned. No single spacecraft saw the whole event. Solar Orbiter caught the opening days. About 12 days in, NASA's Parker Solar Probe, the spacecraft that flies through the sun's outer atmosphere, and the WIND satellite each caught overlapping intervals. Finally, on September 9th, Stereo A, a probe that watches the sun from a completely different angle than Earth, recorded the final act. 4 spacecraft, 4 partial recordings. Each one, on its own, looked like a separate, unremarkable event. The 19-day monster was hiding in plain sight, chopped into pieces across 4 different mission archives, waiting for someone to notice the pieces fit together. Act 1 of this story is the sun breaking a record. Act 2 is the detective work, because figuring out where on the sun this thing lived and what was feeding it took a fleet of spacecraft, a brand new analysis technique, and one clue that's only visible during a total solar eclipse. The chase. When researchers at NASA Goddard and their international collaborators started stitching the 4 recordings together, the timeline that emerged was unlike anything in the literature. August 21st, eruption, and the burst switches on. Solar Orbiter is listening. The signal holds steady as the source region rotates across the face of the sun. Parker Solar Probe and WIND pick up the baton. The emission isn't sputtering out the way a dying electron population should. Its intensity is fluctuating, rising and falling, like something being periodically re-energized. Early September, instead of fading, the burst climbs toward its brightest phase, more than 2 weeks after it began. Then Stereo A watches it finally die, 19 days after it started. Previous record, 5 days. This event, 19. The team published their analysis in the Astrophysical journal Letters in May 2026, and the title they chose tells you how unusual this was. They called it an unprecedented 19-day burst behaving as a Corotating electron reservoir. Krupar et al., AppJ Letters, May 14, 2026. Site on screen. Accuracy brand. A reservoir, not a leak, not a fading echo. A storage tank of high-energy particles, rotating with the sun, staying full for nearly 3 weeks. But a reservoir needs 2 things, a container that doesn't break, and something filling it. Finding both took the investigation in a direction nobody expected, starting with a structure most people have seen in photographs without ever knowing its name. Gravity moment. Before we open that door, a piece of history worth sitting with. In 1859, the sun erupted directly at Earth. Telegraph systems, the internet of that era, failed across 2 continents. Some operators reported sparks from their equipment. Sky glow so bright that people read newspapers by it at midnight. That event lasted days. The machinery behind the 2025 signal ran, in some form, for 19. Different phenomena, but the same engine. Keep that in mind for everything that follows. The detective work. If you've ever seen a photograph of a total solar eclipse, you've seen the answer to this mystery without knowing it. When the moon blocks the sun's disk, the corona blazes into view, and stretching out of it, you can see enormous pointed structures, shaped like the spike on an old cavalry helmet. Astronomers call them helmet streamers. Helmet streamer, a giant V-shaped magnetic structure in the corona. A helmet streamer is what happens when closed loops of magnetic field, arches anchored to the sun's surface at both ends, get stretched outward by the solar wind into a long, tapering point. They are among the largest coherent structures the Sun builds. And critically for our story, a closed magnetic loop is, by definition, a container. Field lines that arch up and come back down can trap charged particles between their foot points. The research team suspected the burst was living inside one of these. Proving it was the hard part. You can't exactly point a camera at radio waves and see where they're coming from, so they developed a new analysis technique using data from the stereo emission, using the properties of the received signal to triangulate the emission's origin, and the trail led straight back to a massive helmet streamer anchored above the active region where the whole event began. Container found. That solved half the mystery. The container was real, and it was enormous. But a container alone doesn't explain 19 days. Remember the rule: the cage always leaks. Trapped electrons scatter, collide, radiate away their energy, and drain out within days at most. For the signal to persist, and brighten 2 weeks in, something had to be pouring fresh electrons into the streamer repeatedly. So the team went looking for the pump, and they found it, in triplicate. Coronagraph records showed that the same active region hadn't erupted once. It had erupted 3 times, in a rhythm that lines up almost perfectly with the burst's life story. The first coronal mass ejection launched on August 21st, the same day the burst began. That's the ignition. The eruption injects the initial population of energetic electrons into the streamer. The second CME erupted on August 30th, and it arrived alongside a surge of a different kind of radioactivity, the rapid-fire chatter of fresh electron beams. That's a refill, new particles dumped into a reservoir that should have been draining. The third came on September 4th, right before the burst reached its brightest phase, a final top-up, powerful enough to push a 2-week-old signal to its peak intensity. Aug 21, ignition, Aug 30, refill, Sep 4 final surge. 3 eruptions from one region. Each one either dumped fresh particles into the magnetic trap or reshaped the field just enough to keep the emission alive. The reservoir wasn't defying physics, it was being maintained by a sun that kept firing from the same spot for 2 straight weeks. And step back for a second, because the way this was solved matters as much as the answer. This event was invisible to any single observer. It took solar orbiter near the Sun, Parker inside the corona's edge, wind at Earth, and stereo A off at an entirely different angle. A fleet, scattered across the inner solar system, none of them aware they were recording chapters of the same book. Which raises the question the researchers themselves have been careful about. How many events like this have we already missed? Recorded in fragments, filed as routine, never stitched together. That question is uncomfortable, but it's not the most uncomfortable part of this story, because when the team worked out what the reservoir mechanism actually implies, for the physics and for the timing, they found the part that still doesn't have an answer. Put the whole picture together, and here's what the Sun actually did in the late summer of 2025. It built a magnetic storage tank the size of many Earths, stacked end to end. It filled that tank with electrons accelerated to enormous energies. It rotated the entire structure around itself like a lighthouse beam, sweeping the signal past one human spacecraft after another. And every time the tank started to run dry, it erupted again, reloading its own experiment 3 times, with almost mechanical timing. Nothing about that violates known physics. Every ingredient, streamers, CMEs, trapped electrons, is textbook. What's new? What earned the word unprecedented in a peer-reviewed title is the combination and the duration, the Sun sustaining a coherent particle reservoir nearly 4 times longer than the previous record, through a self-refreshing cycle we'd simply never caught in the act. And the researchers are explicit about why catching it matters. Those trapped electrons are the tracer dye, the harmless, visible signature of a region that is also capable of producing the dangerous output, solar energetic particle storms. The radiation that punches through satellite shielding, degrades solar panels, disrupts aviation routes over the poles, and forces astronauts into shelter. Radio burst equals harmless tracer. Particle storm, a region that can sustain and refill a particle reservoir for 19 days, is a region announcing that its magnetic engine is running hot, repeatedly, from the same location. Learning to read that announcement is the difference between forecasting space weather, the way we forecast hurricanes, and being surprised by it. If you think surprised is an exaggeration, in February 2022, a single, fairly ordinary geomagnetic storm caught a batch of freshly launched Starlink satellites at low altitude. The storm heated and puffed up Earth's upper atmosphere, drag spiked, and roughly 40 satellites fell out of the sky and burned up, days after launch. That was a minor storm. Space weather already costs real money and real hardware in the mildest cases we experience routinely. Now consider the timing of everything you've heard. This 19-day event happened as the Sun approaches and rides the maximum of its roughly 11-year activity cycle. The analysis was published in May of 2026, and in the very week this video is being made, the end of June, beginning of July 2026, the Sun fired off an X-class flare, the most powerful category there is, with geomagnetic storm conditions forecast within days. The engine is running hot right now. But here's the thing I promised you at the start. The part scientists still can't fully explain. Gravity moment 3. The refills explain why the reservoir kept getting new particles. They do not explain why the container held. Long-duration bursts like this remain vanishingly rare, and researchers still do not fully understand how a magnetic structure keeps energetic particles confined for that long. The cage that always leaks didn't. For 19 days. The mechanism of that confinement is an open question, in the published record, right now. And that open question is not a small one, because confinement is the variable that sets the ceiling. If the Sun can hold a charged particle reservoir together for 19 days, the honest follow-up is, what's the actual limit? 25 days? A full rotation? More? Nobody currently knows, because until this analysis, nobody knew 19 was even on the table. There's a second implication, quieter, but arguably bigger. This discovery wasn't made by pointing a new telescope at the Sun. It was made by re-examining data we already had. 4 archives, 1 new technique, and the willingness to ask whether separate events were actually one, which means the history of solar observation, decades deep, may contain other monsters filed away in pieces. The next record breaker might not be waiting on the Sun. It might already be sitting on a hard drive. That's why missions like Parker Solar Probe and Solar Orbiter matter beyond the pretty pictures, and why the fleet is about to get reinforcements watching the Sun-Earth system from new vantage points. Every additional angle shrinks the blind spot that almost hid this event. The Sun is not becoming more dangerous. It has always been this dangerous. What's changing, slowly, mission by mission, technique by technique, is our ability to notice. For 19 days in 2025, our star broadcast a message on a frequency we were technically recording, but not truly hearing. We heard it 8 months late. The next one, we might hear live. And what we do with that head start, for our satellites, our power grids, our astronauts, is the entire reason this field exists. So let's give this story its honest shape, because it deserves better than a scary headline. The Sun produced the longest radio burst ever recorded, 19 days, against a previous record of 5. The signal itself never threatened anyone. Radio waves are the gentlest thing our star emits. The detective work that followed is genuinely one of the best examples of modern heliophysics working as intended. 4 spacecraft, a new triangulation technique, and a published answer within months. A giant helmet streamer, acting as a particle reservoir, refilled by 3 eruptions from a single relentless active region. That's the explained part. The unexplained part, how the confinement lasted, and how long it could last, is now an open frontier. And it's a frontier with practical stakes, because the same magnetic engines that trap harmless electrons also launch the particle storms that our satellite-dependent civilization is, frankly, still underprepared for. We got a 2-continent warning shot in 1859, a 40-satellite reminder in 2022, and we are, as of this week, sitting inside the most active stretch of the current solar cycle. The Sun has been running experiments like this for 4.5 billion years. We've been capable of noticing for less than one human lifetime, and this event proved we're still missing some of them even when our instruments catch every note. If this made you look at that familiar star a little differently, that's the right response. Not fear, attention. The universe rewards attention, and if you want to see what happens when a star's magnetic field doesn't just trap particles, but becomes so strong it can erase you from 1,000 kilometers away, there's an object out there called a magnetar that makes our sun look like a nightlight. That story is next.